You are welcome to Math Demystified.
This question is asking us to find the determinant of a 2 by 2 matrix. So we are given P equals 3, 2, 1, 0. That's what we are given. And you can rewrite this as determinant of P because they ask us to find the determinant. You can write it like this, or you could just use this symbol to represent the determinant. So, and when you use that symbol, you can even rewrite this as this 3, 2, 1, 0 using this symbol. So you can use any of these three symbols to represent it. How do we do it? Now, we are going to be multiplying and subtracting. We are going to be crossing the diagonals. So this diagonal is called the leading diagonal, followed by this one. This one is called the leading diagonal. So you multiply the leading diagonal, in this case 3 times 0 minus then the other diagonal, which is now 2 times 1. Whatever you get is the determinant. And in this case, it is 0 minus 2. And the answer is minus 2. In this question, we are asked to find the inverse of a 2 by 2 matrix. I would have loved to use 1, but I want us to have more understanding because we will need this in the next question. So we need the knowledge of this in the next question. So I want us to actually understand how to do it. I will do the first one. By the time I get to the second one, it should be better. By the time I will get to the third one, we should be doing it together. So let's get started. I'm looking at the first one. We want to find the inverse of this. For us to find the inverse of this, we're going to do two things. Number one, we want to get the determinant that we just did in the previous example. When we get the determinant, then you put 1 over the determinant. Then I will not teach you what you're going to do. So the inverse of this, let me use I for the inverse. The inverse of this will be 1 over the determinant. The determinant, if you remember what we did, the leading diagonal minus this other diagonal. So when you multiply this by this, you get 3 minus this by this. You give me minus 8. This is minus 8. And there's a minus in the formula already. So by the time I add 8 to it, okay, so it's going to be that. Then what you need to note is that this value here will come over here, and this one here will come over here, which means they will change position. The leading diagonals will change position. So you have 1 here, and you have 3 here. Then the other ones will remain where they are, but you multiply them by negative. So when you multiply this by negative, it becomes 2. Multiply this by negative, it becomes minus 4. So let's rewrite it. So this is now going to be 1 over 11. And that is 1, 2, minus 4, 3. And some may even decide to bring this inside, and that will be 1 over 11, 2 over 11, minus 4 over 11, and 3 over 11. This is the answer, this is the answer, this is the answer. Any one of them is the answer. But it's better for you to either leave it this way or this way. So I'm only using the I to represent the inverse. Or I may even say, let's call this, if I call this I, if I call it I, then this symbol will be very, very necessary for me. So I'll put minus 1, minus 1, minus 1 on top to show that it is the inverse of I. So if they call it A for you, and you're looking for the inverse, then it becomes A, this is by minus 1 to show that it's the inverse you are calculating. I hope you understand that. or rather, let's just call it A right now. A. So this is A, and this is A. So this is A. So you can see that. So I'm going to call this B. I'll call the other one too C, so we can see it at a glance. So let's call this B originally. If I call it B originally, 2, 5, 3, 8. I want to find the inverse. That will be B. Hope you got what I'm talking about. So we write 1 over the determinant. This and this will give me 16 minus this times this is 15. Then we open the bracket. We alternate the leading diagonal 8. 2, multiply this by negative minus 5 minus 3, and that is my answer. This happens to be 1 over 1. 1 over 1, and 1 over 1 is what? Is 1. So my B inverse is just 8 minus 5 minus 3 and 2, because 1 over 1 is 1. This last part, let me call it C. C is 6, 3, 2, 1. So that C inverse will be 1 over this times this is 6 minus this times this is 6. Let's change that. We're going to have 1, 6. We're going to have minus 3. I'm going to have minus 2. My answer is going to be undefined because 1 over 0, got it? Look at it. 1 over 0 minus, this is 1, 1, this is minus 3, this is minus 2, and this is 6. This part, let me show you properly. This part is undefined. Any number over 0 is undefined. So it has no inverse. Has no inverse. I want to use method of matrices to solve them. Okay, so what do we do here? Now let's separate them so we can introduce matrices. Do this. Put the numbers in there. That will be 3 minus 4, 7. This one means 1y. That is y. 1 will be there. Then create another matrix and put the unknowns as a column matrix. Then equal to what we have over there, 1, 23 also as a column matrix. That's the first thing you want to do. So you will discover that if you decide to multiply like this, the way we have done before, you will say that 3 times this will be 3x, all right? And this times this will be minus 4y. So if you add it up, you're going to have this equation. If you do the same thing for this one, if you add it up, you're going to have this equation. So you see that what we have here is exactly what we have in this thing. So what's the next thing you're going to do? You're going to find the inverse. You're going to find the inverse of this matrix. Inverse of this matrix. When you get your answer, you use to multiply both sides. Let's do that. Let's take our time and solve this question. So what is the inverse? Let's go do the inverse and plot it in. The first thing we're going to do here is to find the determinant. And the determinant is, we're going to do the inverse will be 1 over this and this will give you 3 minus this and this will give you 28. And there's another minus there, so making plus 28. Which when I add it up will give me 1 over 31. I hope that is clear. 1 over the determinant. Then how do we always do the inverse? We take this one, we swap the leading diagonals. This will be 1, this will be 3. Multiply this one by negative, you get 4. By negative, you get minus 7. So this is going to be my inverse. So I'll multiply this part and this part by the inverse. And when we do, everything will still remain intact. because we are multiplying both sides by the same quantity. So let's do that briefly. So right here we have 1 over 31, 1, 4, minus 7, 3. Then we have this 3 minus 4, 7, 1. Then we have x, y equal to, bring the same thing over to the other side, 1 over 31, 1, 4, minus 7, 3, then bring this one, 1, 23. I'm sorry for putting it over here. So this one, this is a matrix. So 123. These ones are fractions of a matrix. Let me repeat what I just said. This is the question. We are transforming this into a matrix form to find the inverse of this, which is 1 over the determinant. Then you swap the diagonals and multiply them, subtract the difference between them. And this is my inverse. This is also the inverse. Whatever is left, taken from the original equation. So what's the next thing? Now, keep this one constant, then multiply this matrix. Let's take our time, let's solve it. What will this give us? We have 1 over 31. This, multiplying this will give me 3. This will give me 28. When you add it up, you get 31. When you do the same thing for this side, you will get 0. When you take this one to multiply this, is 320. This multiplying this will give you 21. Then this one multiplying this will give you 21. That's 0. Minus 21 plus 21 is 0. Then take the same thing, multiply this one. This multiply this will give you plus 28 plus 3. That is 31. So this one is taken care of. So we have x and we have y, which is equal to, over here too, let's multiply this one. This is 1 over 31. So let's multiply this. Let's see what's going to give us. This one will multiply this to give me 1. This will multiply this, and that will give me, this here is 2, remaining 1, 8, 9, that's 92. So right here I'm going to have, so it's 99, 93 rather. It's going to give me 93 there, because this is 1 and this is 92. Add that to that, I'll give me 93. So do the same thing for the lower part too. If I pick this one, I multiply by this, I get minus 7. Yes, minus 7. And by the time I do this one, I'm going to get 69. When you add them up, you're going to get 62. 62 right there. So look at what we have. When we started, one of the few questions where we solved, we learned how to use a single number here to multiply everything you have inside. If you remember, when you're multiplying by a scalar. So this one, when it comes here to multiply, is going to be divided because it's a fraction. When this one divides this, you're going to have 1 there. This will remain 0, because 0 divided by anything will give you 0. Over here, you're going to have 0, and here you're going to have 1. So I have x, y here, and this is equal to, when this one divides this one too, you're going to be having 3 over there, and divide this one, you're going to have 2 right here. So this is what I have left. So what are we going to do next? Now, that simply tells me that, looking at this, this is the same thing as 1. This is the same thing as 1, because if you take this and multiply this, this times this will give you x. This times this will give you 0. Take this again, multiply. This times this will give you 0. This times this will give you y. So you end up having x, y, now being equal to 3, 2. xy being equal to 3, 2. So from here we can now conclude that our x is equal to 3 and our y is equal to 2. Therefore, x is equal to 3 and y is equal to 2. And that's how to go about it.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.